Hello students, today we will see the next section in Truses, that is method of sections. In the previous examples we have seen how to solve any given truss problem by using method of joins. Now we will see method of sections. Hello students, now we will see the method of section. It is a method wherein we are going to find the forces in few members. By using method of joins, we were able to find forces in all the members. Now, I'll show you this example wherein, if you can see, I've written find forces in the members GH, CG and CD. There are around 10 to 12 members in this truss. But if I am concentrating on only few members, then how to go about? If I go with the method of joins, it is going to be time consuming. So the other method wherein I can find out the forces in the selected members, so for that case I need to use method of sections. If you see the member GH, CG and CD, they are like on one side of the truss. So in method of section, what we need to do exactly? We need to cut the truss. We need to have a section plane such that it is going to cut the truss into two parts. May not be equal. It could be any size. Maybe a small size coming on one side and a big size going on the other side. Now in this case, what I want to do is, I want to cut this truss such that I can find the forces in all the members if possible with one single section. If not, I can take two sections or three sections. Now if I am taking a section in this truss, what happens? The point is, I need to cover up all the three members with one single cutting plane or the section plane. Now, if I draw a vertical line over here like this, the line which is going vertically down, in that case, I'm cutting all the three members. The member GH, CG and CD. You have to take care that you're not cutting more than three members. There might be a special case wherein you might have to cut more than three members, but that would be very rare. Now, if you see, if I draw one line over here, a vertical line, and if I say that is going to be the section plane or the cutting plane, then in that case, I'm having only three members. And those are the three unknown forces that I need to calculate. So what I'll be doing is, I'll take one section plane and I'll draw here one line. Now you can see that I have drawn one cutting plane. That cutting plane, the one line, is the cutting plane which is cutting the truss. Now that truss, I can take any of the sides for the calculation purpose. Take the smaller side or take the bigger side. I will prefer taking the smaller side because that would be easier for me for the calculations. Now, what we have to do exactly in method of sections? The routine remains the same. The routine as in, we have to first check for the stability criteria. We have to find out whether the truss is stable or not. If the truss is stable, then we move ahead in calculating the forces in all the members or the selected members. Then, after that, we need to find out the reactions. In this case, I'm having one hinge support and a roller support. Hinge support having two reactions and a roller support having one single reaction. So the total number of reactions I'll be having over here is 3. So I'll go ahead with solving this problem. We will find out how many members we have in this case. Now we will see the number of joints. We can see that my right hand side is equal to left hand side, that is the number of members, which is 13. I can conclude that the truss is a perfect truss. Now, the next step that we do in solving the trusses example is we find out the support reactions. Now, to find out the support reactions, hinge support is having two reactions, and roller support is having one single reaction. Now, in this truss, if I see, I have two horizontal forces. One is the horizontal reaction at A, and one is the horizontal force 6 kilonewton acting at I. Now we can see that the assumption that I had done of the horizontal reaction acting towards right is wrong, because the value that I'm getting for horizontal reaction is negative. That means the reaction force is acting towards left. Now, I'll move on to the next condition, that is the vertical direction. I have two vertical reactions, VA and VE, and I have three vertical forces, 2 kilonewton force acting at B, 6 kilonewton force acting at C, and 4 kilonewton force acting at B. Now, I need to find out the vertical reactions. So what I'm doing is I'm going to take moment about A. If I'm taking moment about A, what happens? The horizontal reaction acting at A becomes 0. The moment effect because of that becomes 0, and the vertical reaction effect, the moment caused by that, is also 0. So all I'm going to have is the 6 kilonewton force acting at I, 2 kilonewton force acting at B, then 6 kilonewton force acting at C, 4 kilonewton force acting at D, and the vertical reaction acting at E. So now we can see that the vertical reaction acting at E happens to be 8 kilonewtons. And since the answer is positive, I can say that my assumption of vertical reaction at E acting upwards is correct. Now what I'll do is I'll put up this value of VE as 8 in my equation of Y, that is the vertical direction. Now I can see that the vertical reaction at A happens to be 4 kilonewtons and that is acting upwards. Now I'm done with two steps, the regular steps that we do usually in solving the trusses example. Now we need to find out the forces in the selected members, that is GH, CG and CD. Now we have already taken a section plane, that is 1 1. Now what I will be doing is I will draw that part of the truss, either the right side part or the left hand side part. Draw any one part, and for that part we will try to find out the forces. Now I'll be taking the right hand side part, that seems to be smaller for me, so I'll just take that part and I'll redraw that structure. Now, what I have done is I have drawn the right side part of the truss. Now you can see that the force member, that is GH, I have labeled it as F1, CG I'm calling it as F2 and CD I'm calling it as F3. Now I need to find out this angle alpha as well as theta. Now, if you look in this truss, the original example, the question that we have, the dimensions are given to us. We need to just calculate the angle. Now, if I want to find out angle of CG with respect to the horizontal, I can use the tan ratio. I know this height, that is 3 meters. I know this width as 3 meters as well. So that would be 45 degrees. Now to find out the angle alpha, that is angle of HG with respect to the horizontal. Now to find out that angle, I know this height. This happens to be 1.25 meters. I know this length, that this is 3 meters. So again I can use the tan ratio, and tan ratio is nothing but opposite side upon adjacent side. The angle that I have got for alpha happens to be 22.62 degrees. Now, what we need to do while solving any example by method of sections. The easier method in doing this is we need to take moment about any one point. Now, for example, if I take moment about C, what happens in that case? You can see that F2 is approaching C, F3 is also approaching C. So the moment of these two forces will become 0. So if that happens, at least I'm making my calculations easier by making these two forces as 0. I can find out the force in the member GH, that is F1. Now before I move on to that, you can see that I have a 4 kilonewton force acting at D. So I need to show that also. At C, I'm having this 6 kilonewton force. If I take this 6 kilonewton force, what happens? That will become a 0. The moment because of that force will be 0. So it is not going to affect the equation. So what I'll do is I'll write the equation for moment about C. If you look at this equation, what I have done is I've taken moment of this force, that is the 8 kilonewton force. Then I've taken moment of this force, that is the 4 kilonewton force. I know the distances between CD and TE, that happens to be 3 meters. You can see in the question, this distance is 3 meters as well as this distance is 3 meters. Now what I've done for this force, the F1 force, I've resolved this F1 force at point H. If I'm doing that, what happens in that case? If I resolve this force which is going in this direction over here, if I resolve it, I have the cos component horizontal one and the sine component which is going vertically up. Now the sine component, the moment at C will be 0. So again I am reducing the calculations over here. So this is the final equation I'm having. Now what I will do is I'll try to find out the value for F1. I'm getting the value as negative. That means what? The force nature, the nature of the force in F1, that is the member GH, happens to be compressive. Now, I'll move on to the next point. If I move on to the next point, say G, what happens in that case? Again, I'm making two forces moment as 0. Now, if I make two forces moment as 0, that is F1 and F2, I can find out the moment for force F3. If I take moment about point G, F1 and F2 will be 0, so I can find out moment for F3. I won't be taking the 6 kilonewton force because that doesn't lie on the side which I am solving. This 3 kilonewton force is making an a clockwise moment, whereas the 8 kilonewton force is going to make anti-clockwise moment. Now, I can see that the F1 force is coming out as positive, that is 8 kilonewtons. That means the force in the member the force in the member CD is coming out as 8 kilonewtons. Sorry, I'll just make this change. That is F3. F3 happens to be 8 kilonewtons, and that is tensile. Now, the next point that I can do is I can take moment about point B. If I take moment about point B, so, and in that case, I'll be having the forces F1 and F2 which are inclined. So, I can resolve them at point G itself. If I do that, I'm reducing the calculations again, because for both the forces, the sine component will be passing through the moment center, that is B. And if that is the case, the forces will be creating a zero moment. Now, if you look over here, moment about D, this is going to create an anti-clockwise moment. Moment due to this force will be 0. Moment due to this force will be again 0. The sine component of F2 will be 0. I will have to consider the cos component, same as with F1. I have got the value for F1. I'll substitute this value for F1 in the equation for moment about D. Now, if you see in this case, I'm getting the value as negative. That is 0.65 kilonewtons. So I can say that the force is compressive. The calculation over here is positive. So this will be a positive answer and the force will be tensile. Okay. So in this way we have found out the forces in all the three members which were required as per the given question. So all we need to do is tabulate the result for these three forces only. We are not going to find out forces for remaining members. The force in member GH, I am calling it as F1. In CG, it is F2, and in CD, it is F3. We have seen that when I have taken the section. Now I know the values for that. I just put on the values over here. F1 happens to be 9.17 kilonewtons, compressive. So, okay students, now I guess you might have understood what is method of sections. The advantage of using method of sections over method of joints. The only advantage I can see over here is it reduces the number of calculations that we do if we need to find out the forces in few selected members. All we need to do is we need to take a section and then move ahead. I hope you have understood this video. Thank you.